Cool. Well, I hope we get justice for Logan, and I hope you really enjoyed that talk by Ron Keesing earlier. Our next talk is one of the most anticipated ones, and it is my pleasure to introduce Alex Albert from Anthropic. Alex joins us where he initially worked at Anthropic as a research engineer, but now handles developer relations, helping people do more with Claude. Today, he's going to talk to us about building with Claude and MCP. Alex, over to you.
Thanks, Ado. And hello, everyone. Thank you to Sourcegraph for having me today. I'm going to share a few slides here. So one moment while I get this pulled up. All right, we should be good to go. So like Ado said, I'm Alex. I lead developer relations at Anthropic. Today, I'm going to be talking about building on Claude and specifically building with MCP, which I'll dive into in a few slides. But in the nature of the summit today, I wanted to start with coding. Claude 3.5 Sonnet, in our opinion, is one of the best models in the world at coding across the board. There's a few different ways we measure this. Externally, people have started to create these sort of agent benchmarks where they test the models on a variety of agent tasks and they see how well the models can perform in comparison to something like a human developer. So you can see this chart here. This is from Meter, which is the Model Evaluation and Threat Research Organization. They've benchmarked a variety of models, GPT and Claude models, against humans in certain amounts of time. What they found was that Claude 3.5 Sonnet started to reach the time comparison of a human that would take 30 minutes or even up to an hour in some cases in terms of the tasks that it can complete. Now, the caveat here too is that this is from August. So this was before we released our latest version of the 3.5 Sonnet model in October. I would expect that if we added this to that graph as well, the bar chart here would extend even further and further. Now, at Anthropic internally, one way we measure this sort of coding performance alongside this agent performance is on a benchmark called SweBench. SweBench is a collection of real GitHub issues that test the AI's ability to code and solve problems. So this requires an understanding of code bases, how to actually modify code, and how to actually then pass unit tests and debug errors that it may run into. So on this benchmark, SweBench, the new Claude 3.5 Sonnet achieves a 49%. That beat the previous state-of-the-art at the time of our release, which was 45%. So nearly a 4% jump there in the score. Now, since then, the score has been surpassed even more. And I think we're up to like around mid-50s now on this benchmark. But the good thing is with that, all those new scores are all using 3.5 Sonnet as well, just different frameworks that are orchestrating it. I don't think we're at the end of maxing out the juice out of 3.5 Sonnet. I think we could probably get up to near 60% range with this model. So one broader point to note, though, as we are doing all this testing and we are evaluating models on code and on agents and on just deploying them into production settings, we kept running into this problem around context. And we realized that really the models at their limit are only as good as the context that you can provide to them. Now, this got us thinking, how can we make this an easier process for developers? If we're struggling with this internally, I'm sure, and I know from my own conversations with builders and developers out there, that they're also struggling with the same problems. So this led us to create the Model Context Protocol, or MCP. MCP is an open protocol that enables seamless integration between LLM applications and your tools and data sources. So there's a few parallels that you can compare MCP to from previous web standards and protocols in the past. The first most obvious one is APIs, which standardize how web applications interact with a backend service. Second one is something like LSP for IDEs, which standardizes how an IDE interacts with language-specific tools. And now we have MCP, which standardizes how an AI application can interact with an external system through three main things: prompts, tools, data, and resources. So what does the world currently look like without MCP? Basically, it's a lot of fragmented AI development. So you'll have a AI app that someone is building, and maybe they want to connect it to some custom data source or data access. So they'll write their own RAG pipeline, or they'll do some custom implementation, and it'll work. But then the next time they want to build another app and they want to connect to maybe that same data source, they'll have to rewrite that all over again. Or maybe there's an external developer and they're doing the same thing. Again, they want to connect to a similar data source or a similar group of APIs. They have to roll their own and basically reinvent the wheel every time. But now with MCP, we can standardize this process. So we can create this layer of abstraction, basically, where we have an MCP client, which is your LLM application. So this could be something like Claude for Desktop or Sourcegraph Cody or a variety of other providers. And then we can basically wrap our data source in this server. So the server will wrap your database or maybe your CRM or your version control software. And then once you have established those two things, you're basically able to make bridges between the client and the server. So any client, any LLM application that supports an MCP client can now seamlessly connect with any MCP server anywhere that anyone created. So there's a few different value props as you're starting to think about this with different hats on. If you're an AI application developer, you'd want to make your app into a client so that you can connect it to any MCP server with basically zero additional work. If you are a tool or an API developer, so you're working on one of those data sources, you could build an MCP server once and see adoption across MCP clients everywhere. If you're an end user using one of the LLM applications, you'll just get a far more powerful and personalized LLM product experience because it has access to all your data. If you're an enterprise, the benefits extend even further. So in traditional software, there's clear boundaries that delineate the work of different teams. So you have front-end versus back-end teams, microservices, different APIs. But LLM applications don't always have these clear boundaries. Prompts are messy, data and tool calls often require access to both front-end and back-end. This is a problem, and MCP creates this clear separation of concerns for LLM applications. So for example, two unrelated teams might be building some chatbot, which uses a shared internal database for RAG. Without MCP, both teams are having to build their own separate RAG implementations. But with MCP, a central team could just focus on building an MCP server for that RAG service, and then each chatbot team only has to implement their MCP client, and then seamlessly they'll be able to connect. So how does this actually work? Like I said, there's MCP client, there's MCP server. The MCP client queries for resources, invokes tools, and interpolates prompts. The MCP server exposes resources, it exposes tools, and it also exposes these prompt templates. So tools are things like functions and things that can be invoked by the client, like maybe you want to retrieve or search or send a message or update database records. Resources are data or content that are exposed by the server on that initial bridging of the connection. So things like files or database records or maybe a database schema or API responses. And then prompt templates are predefined templates you can expose through your server, which would define an AI interaction. So maybe you wanted to do document Q&A or transcript summary or output in a specific format. So here's an example of how that looks when you connect a client all the way through to something like Salesforce. Let's say you wanted to use like the tool functionality and the end user said something like update this opportunity after the Q4 meeting. This would invoke tools that are exposed through the MCP server because the model would see that has access to these tools and would call one of these. That gets established through this MCP server connection. And then finally, the MCP server wraps Salesforce so it can go and actually update that record there. There's also the resources component to this as well. So on that initial bridge, the server can expose directly to the context window whatever information the server has decided is valuable. So maybe things like account financial data and latest deal information. Now I want to show off a quick demo of what this actually looks like in practice today. So right here, I'm going to pull up my screen. Right here, I have Claude desktop app, and this has been configured as an MCP client. And I've loaded in a variety of tools through 3 different servers: a Brave search server, a local file system access server, and a Spotify API server. So now I'm going to ask Claude within this LM application, hey, can you search the web for the Sourcegraph Virtual Code Summit and let me know when it is? So Claude reads that, of course, like it normally does, but now it sees that it has access to those tools. So it issues a tool call, gets a search result back from the Brave web search server, and then is able to actually finish its output using that information. So it says, okay, this thing is tomorrow. I filmed this yesterday. So December 12th, now I go on and I say, okay, that's tomorrow. I need to make a slide deck. Can you help me get in the zone and play some study music on Spotify? So Claude can now look at what tools it has access to in its context window that are related to Spotify. It finds and searches for a lo-fi productive music, focus music playlist, and then it actually can go start a song here, which it did on my local Spotify app on my computer. So now that that's playing, we can continue on, and now basically I ask Claude, okay, I need to start thinking about what I want for this presentation. Can you help me brainstorm some ideas? And then Claude, can you go out and read for information on MCP? Since MCP is, of course, past Claude's training cutoff data, it doesn't have access to any information on that. So I actually just ask it to go make a web search and then read up on it like a person would, and then come back to me with relevant information on it. So it makes that web search. Again, it issues this tool call to the Brave web search tool, gets search results back, and then is able to actually draft a flow here of how I could make some slides about MCP. And now finally, so that I can save this outside of the chat window and build off it into an actual slide deck, I want Claude to add this as a text file on my desktop. So Claude can then go right to a file on my desktop using that file system server, and then takes a second here. It actually hits an error, but it's able to error correct out of that. Try it again, use the different tool. And then finally, it'll write here to this new file, MCP presentation outline. And then I think I just dragged it right over so you can see that it indeed did write a new file. So that's pretty powerful. I think this is a vision of this future and where the AI will not be confined to this chatbot. It will actually have access to all the same things that you would have access to, perhaps even more, because it can use all these APIs pretty seamlessly. And we're going to start to see integrations really start to take off. You can go use this right now in other clients as well. Sourcegraph Cody has implemented MCP support. So here is an example of connecting it to a local Postgres database. So you could expose like your schema to Cody. We've also had a ton of momentum since launch. If you want to go check it out, we have a ton of server implementations and a TypeScript and a Python SDK. Also tons of other official integrations from companies like Sourcegraph, of course, Cloudflare and others, GitHub Copilot, Block, Apollo, a lot of companies, big enterprise customers as well, starting to look into implementing MCP. It's only been about 2.5 weeks since launch. Tons of devs, individual devs are making resources as well. If you're interested in MCP, I highly recommend you make some resources and try it out as well. Feel free to tag me on Twitter. I'm at Alex Albert with 2 underscores after. I'd love to take a look at that. Finally, to get started, check out our GitHub repo. Go to modelcontextprotocol.io. All the links will be there. All the docs are there as well. And with that, I want to say thank you. And I think we're going to move over into some Q&A.
We are indeed. Thanks, Alex. Everybody is absolutely enraptured with MCP and all this stuff, and they've got many more questions. Wow. So I'm just going to jump in and start here. So from Brigitte, we have what's the difference between OpenAI API's function calling and tools versus MCP? Is MCP basically an alternative API spec to OpenAI API, the tools part, or is it more than that?
So I would say the direct comparison to OpenAI's function calling is our tool use API. And the tool use API is kind of a subset of MCP. That's specifically focused on just the tools component. But MCP is more than just that. It's really about establishing these standardized bridges and connections between data sources and integrations. So thinking about like this sort of back and forth bilateral communication pattern between applications and servers, which is not something you really necessarily get with the tool call, which is just more of like a spec for the model itself to follow a specific format.
I'm gonna inject my own question. Is there any context ranking going on in this world you're envisioning?
Yeah, so context ranking would be entirely implemented in the server, which is why it makes this kind of powerful, or the client as well. So you could do re-ranking on either side. It kind of offers the developer the flexibility there. So let's say you're creating a server for something like Salesforce, as I mentioned, but you're like, okay, I actually need to pass back the information in this specific format every time because I found this just works the best for giving to models. You could do that yourself. If you're in the client and you're trying to connect to multiple different servers and you're like, I always like to present Salesforce information first, you could implement that ordering and ranking as well. So it's not defined by us or the protocol. It's really allowing the flexibility and the customizability to the dev.
Nice. So people are asking for more links and resources about MCP. So I'm guessing that a lot of people are going to go check it out. I got a question from YK here. He's asking about the benchmarks that you were talking about. So how realistic is the chatbot arena, LM-Sys's ranking of models when it comes to coding? Are there better benchmarks to look at for real tasks?
Yeah. I think the LM-Sys team is doing great work, but there's a lot of limitations with the leaderboard as it stands. First, it's mainly based on toy problems. It's really hard to evaluate real software engineering problems in that format. So they're actually addressing this. They're starting to build like a more real life thing where it's like a extension that goes in your IDE and you can like compare two diffs across models. But in the current form, when you log onto the website and you just put in like make me a Python function thing, like that's not really representative of real coding tasks at all. So things I look at, some benchmarks called like Live Bench. There's also IDER Chat, AIDER. Those people all run their own independent benchmarks. And then I really think SweBench is one of the better ones too. Of course, people are trying to hack it to some degree by like scaffolding in certain ways. So you have to kind of read between the lines and figure out who's doing it right. But SweBench is pretty representative of real world problems too. So that's one I pay attention to.
Wow. Yeah, I don't think we spent enough time talking about how critical benchmarks are to all of this.
Yeah.
Well, hey, last question. We've got about a minute left. Tell me about 2025. What's top of mind for you? What's most important for Code AI?
Yeah, I feel like I'm a broken record now repeating this, and it's a bit cliche. But 2025 is going to be a year of agents. I'm more bullish on it than ever with MCP. I think there's going to be a real wow moment once people realize that once you can connect a model to all your data sources, there's a lot of kind of latent ability that just hasn't been exposed yet. And I think people are going to be very surprised at what even current models are capable of doing.
That's pretty exciting. That's even when the coding benchmarks aren't really that sophisticated yet. You still think we'll hit it next year?
Yeah, I think we will. I think by the end of next year, we're going to be in a very different place in relative to coding standards, which will probably surprise and shock a lot of people. So,
well, we are all looking forward to being surprised and shocked.
Yeah.
Hey, Alex, thanks so much for joining us. This has been awesome. Really
Thank
awesome.
you. Yeah, thanks for having me.
Folks, we'll see you in a few seconds in the next session.